This is section 4.2, apply congruence and triangles. Two geometric figures are congruent if they have exactly the same size and shape. Imagine cutting out one of the congruent figures. You could then position the cutout figure so that it fits perfectly onto the other figure. So for example, these figures would be congruent because you could cut this out and set it on top of this one. Same thing with this guy. You could cut him out and set him on top of here or on top of here if you flip them over. They're the same size and shape. Now, these shapes are not congruent. Maybe they have the same shape. They're all triangles, but they're different types of triangles and they're different sizes of triangles. So these are not congruent. When you have two congruent figures, all parts of one figure are congruent to the corresponding parts of the other figure. When you have congruent polygons, this means that the corresponding sides and the corresponding angles are all congruent. So here's how you would write a congruence statement. We have congruent statements for angles and for segments. We can have them for triangles or for polygons also. When you write a congruent statement for two polygons, always list the corresponding vertices in the same order. You can write congruent statements in more than one way. Two possible congruent statements for the triangles below are as such. These two triangles are congruent, and here's why. We have a pair of congruent sides here, a second pair of congruent sides there, and a third pair of congruent sides there. All corresponding pairs of sides are congruent. Likewise, look at the angles. We got a pair of congruent angles here, pair of congruent angles here, and then a third pair of congruent angles there. We have three pairs of congruent angles also. So when you have all six pairs of congruent parts, you can write congruent statements. So for example, we named this triangle ABC. We're going to say it's congruent to this triangle over here, but we're not just going to put the letters down any way we want. We have to line up what goes with what. For example, angle A goes with angle F. That's why we have A with F. Angle B goes with angle E. That's why we have B with E, so on and so forth. Now, if you didn't want to call this triangle ABC, you could have called it something like triangle BCA. Switch up the order, start with a different letter. But the idea is B is still matched up with E, and C is still matched up with D, so on and so forth. So you can see all six pairs of corresponding congruent parts on the picture. You can also see them listed as statements. Let's identify congruent parts. We're going to write a congruent statement for the triangles. Identify all pairs of congruent corresponding parts. So here are two triangles. Let's list the things that we see. Corresponding angles. I see that angle J is congruent to angle T. Also, angle K is congruent to angle S. Angle L is congruent to angle R. There's your three pairs of congruent angles. They're marked on the picture. Now, we need to do the same thing for the corresponding sides. So for example, segment JK, it's congruent to this segment. Now watch the order. We called that one segment JK. This one must be segment TS. That order matters. Notice how J goes with T up here. J goes with T down here. Segment KL is congruent with segment SR. One more, segment JL is congruent to segment TR. When you have three pairs of corresponding angles that are congruent and three pairs of corresponding sides that are congruent, these two triangles are definitely congruent. So we can write a congruent statement for them. You can name this triangle any way you want. I'm going to call this triangle JKL. And then what I'm going to do is make sure when I name this triangle, the corresponding parts line up. So I know that J goes with T, I know that K goes with S, and I know that L goes with R. This is theorem 4.3. It's called the third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. So what that means is, notice how we have a pair of congruent angles here and a pair of congruent angles here. We don't necessarily know what this angle is. But let's just say, for a simple example, that this is a 50-degree angle. That means this one's 50. Let's say this one over here is 70. That means this one's 70. Well, what's the measure of angle C? You can figure it out. If you know two angles of a triangle, you definitely know the third one. That's got to be a 60-degree angle. Now, 180 degrees in a triangle tells you that. We don't need to do the same math over here. I think you know that's going to be a 60-degree angle as well. So the point is, if you have two pairs of congruent angles in a triangle, that third pair of angles, they got to be the same too. It's impossible for them to be different.